went through this article in another video I did on the dietary wisdom of the great apes on psychopathology, but this is about the impact of polyphenolic food, on longevity and elixir of life and overview. Aging in particularly. Well, actually, before I start, I want to say I'm not a doctor, I'm not a physician, I'm not a DO, I'm not an MD, I'm not an ND, I'm not a chiropractor, I'm not a nurse, I'm not an LPN, I'm not a CNA, I'm not a nurse practitioner, I'm not a dietitian, I'm not a nutritionist, I don't have any medical training whatsoever. So if you have a medical concern or question, ask somebody with a medical degree and a medical license. I'm not such a person. But before I begin, I just wanted to say that, but what you have to understand is aging, and in particularly the onset of age-related diseases. Remember, if you read True Age by Morgan Levine, you'll find out that the diseases of aging are actually the symptoms of aging, okay? They are the symptoms of specific systems aging at different rates, okay? And we can tell this with epigenetic aging clocks. So what you have is you have diseases are associated with tissue dysfunction and macromolecular damage, some of which can be attributed to accumulation of oxidative damage. Recently, growing interest has emerged on the benefits of plant-based diets for the prevention of chronic diseases, including obesity, diabetes, and cardiovascular disease. Several studies collectively suggest that the intake of polyphenols and other phytonutrients, but polyphenols and their major food sources may exert beneficial effects on improving insulin resistance and related diabetes factors, such as inflammation and oxidative stress. They are the most abundant antioxidants in the diet, and their intake has been associated with reduced aging in humans. Polyphenolic intake has been shown to be effective at ameliorating several age-related phenotypes, including oxidative stress, inflammation, impaired proteostasis, and cellular senescence, both in vitro and in vivo, so both in a dish and in a person and in an animal, okay? So in this paper, blah, 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 okay, so we're going to take a look here. I already went through this before in my previous video with chimpanzees. So you got the flavonoids. This is the basic structure. It shows the structure of flavanols, flavothrenols or flavanols, lignans. So your your flavothrenols or flavanols come in your cacao or cocoa. I don't know why people insist on saying cacao these days. Green tea, apple, peaches, and barley. Your lignans come in sesame seeds, grains, brassica vegetables. Okay, resveratrol, grapes, blueberry, raspberry, mulberries. Your phenolic acids, they're coming in the coffee, peaches, prunes, olive oil. You can get them in decaffeinated coffee too. Vanillic acid, you're getting that in berries, onions, horseradish, pomegranate. Curcumin comes in turmeric. Isoflavones, you're getting in your lupine, your fava beans, and your soybeans. Your others, your anthocyanins, your cyanidin, your whatever, blackberries, blueberries, black grape, cherry, strawberry, plums, your apigenin, and your luteolin, celery, broccoli, green pepper, parsley, thyme, chamomile tea, peppermint, and rosemary. Your quercetin you're getting in your capers, your onions, your radicchio, your chokeberry, and your cranberry. So these are the hallmarks of aging. So basically, these phenolic compounds have they've shown to reverse things like neurodegenerative disease. They have anti-cardiovascular disease effects. They have action on gut microbiome, against type 2 diabetes. They help to reverse liver disease or prevent liver disease, and they have anti-cancer effects. So here you see the hallmarks of aging. I already went through this exact thing in a previous video, but not this video series. So you have epigenetic distortion, mitochondrial dysfunction, genomic instability, altered intercellular communication, sperm activity, deregulated nutrient sensing, stem cell exhaustion, loss of proteostasis, telomere shortening, imbalanced metabolism, and cellular senescence. And polyphenols work on all these things. Okay, so that's why they work against the diseases of aging, is because they help with all of the things that cause the diseases of aging. So what is the molecular mechanism of polyphenols and the regulation of aging hallmarks? Aging is a complex process characterized mainly by a decline in function of cells, tissues, and organs, resulting in an increased risk of mortality. This process involves several changes described as hallmarks of aging, which include genomic instability, telomere attrition, epigenetic changes, loss of proteostasis, dysregulation of nutrient sensing, mitochondrial dysfunction, cellular senescence, stem cell depletion, and altered intracellular communication. Okay, so let's see, how does this work? So during aging, epigenetic regulation changes in response to exogenous and endogenous factors affecting various. So what happens is the polyphenols do this. Okay, genomic instability, dietary they basically restore genomic stability. So you have free radicals causing genomic instability, and then boom, the polyphenols are restoring genomic stability by quenching the free radicals. So genome instability is an important hallmark of aging. Left panel, dietary polyphenols can decrease genomic instability. Telomere shortening contributes to aging. Short telomeres lead to mitochondrial DNA damage, introducing senescence. And dietary polyphenols can help with that. So during aging, the increase in radical oxygen species affects proteasomal and autophagy processes. Consequently, proteostasis is lost, as shown by Figure 5. During aging, in response to cellular stress, SIRT1 activity is compromised, resulting in loss of sensitivity to detect nutrients. And Figure 6, oxidative damage to DNA results from accumulation of free radicals within the mitochondrial DNA. During aging, stress or excessive cellular damage favors cellular aging. This process is characterized by irreversible arrest of increased Okay, so what you have here is you have the different phytonutrients and what they do. Okay, so this caffeic acid knocks down adipogenesis, which means fat. It increases this. You can look at this all yourself. I don't feel like going through this. I'm going to post this on my community tab, the different little charts here: resveratrol, curcumin, quercetin, These are the different things that it works on. So this is an EGCG and resveratrol are AMPK activators, SIRT1 activators, TRF2 activators, and they help with telomere shortening. But yeah, I'll just post this on my community tab. So the Mediterranean diet, which is very high in phytonutrients, has a very good effect on the hallmarks of aging. Okay, so healthier dietary patterns reduce the risk of age-related diseases and increase longevity, and may influence positively one or more of these hallmarks of aging. Okay, so these hallmarks include, of course, genomic instability, telomere attrition, epigenetic alterations, loss of proteostasis, deregulated nutrient sensing, mitochondrial dysfunction, cellular senescence, stem cell exhaustion, and altered intracellular communication. So the diet that is typical of Greece, Spain, and Italy pre-globalization of the food system, and which is associated with better health during aging. Okay, and that's what you need to know. Go to oldwayspt.org for more on that diet. Aging in the is a risk factor for neurodegenerative diseases, including Alzheimer's disease, Parkinson's disease. 1 in 10 individuals age 65 or over has Alzheimer's disease, and its prevalence continues to increase with increasing age. Few or no effective treatments are available for aging-related neurodegenerative diseases, which tend to progress in an irreversible manner. What they mean by no treatments, they mean no pharmacological or surgical treatments, but we're going to show some things with the phytonutrients. This review discusses the pathogenesis, with potential therapies including NAD plus cursors, mitophagy inducers, and inhibitors of cellular senescence. So a lot of these phytonutrients and things like niacin and the other B vitamins may be of help. Quercetin is active against neurodegenerative diseases. So berries are well-known fruits for their antioxidant effects due to their high content of flavonoids, and quercetin is one of the potent bioactive flavonoids, although oxidative stress is an inevitable outcome in cells due to energy uptake and metabolism and other factors. Excessive oxidative damage or oxidative stress is considered a pivotal mediator for the cell death and leads to the progression of neurodegenerative diseases. Furthermore, oxidative stress triggers inflammation that leads to neuronal cell loss, Alzheimer's, Parkinson's, Huntington's disease, amyotrophic lateral sclerosis, Lou Gehrig's disease, multiple sclerosis, and so on are the main neurodegenerative diseases. Hence, AD and Alzheimer's disease and Parkinson's disease are the most affected neurodegenerative diseases and cause the most lethality without any effective cure, since Alzheimer's disease and Parkinson's disease are the most common neurodegenerative diseases. Therefore, in this study, we will describe the effect of oxidative stress on Alzheimer's disease. So targeting oxidative stress could be a very effective way to prevent and cure neurodegenerative diseases. Thus, the nuclear factor erythroid-2 related factor NRF2 and heme oxygenase are potent endogenous antioxidant modulatory pathways, which also show cytoprotective activities. Okay, so modulation of NRF2 and HO1 signaling pathways through a biological approach could be an effective way to treat neurodegenerative diseases. Quercetin is a natural polyphenol which protects from neurodegeneration remarkably by suppressing oxidative stress and inflammation. Thus, quercetin could be a very effective agent against neurodegenerative diseases. They will discuss the benefits and challenges of quercetin to treat neurodegenerative diseases. Okay, this is a little thing here, a little map here. The effects of quercetin on amyloid beta plaque and tauopathy of neurodegeneration. Neuroprotective effect of quercetin against the detrimental effects of LPS in adult mouse brain. Chronic neuroinflammation is responsible for multiple neurodegenerative diseases such as Alzheimer's disease, Parkinson's disease, Huntington's disease, liposaccharide LPS is an essential component of the gram-negative bacterial wall and acts as a potent stimulator of neuroinflammation that mediates neurodegeneration. Quercetin is a natural flavonoid that is abundantly found in fruits and vegetables and has been shown to possess multiple forms of desirable biological activity, including anti-inflammatory and antioxidant properties. This study aimed to evaluate the neuroprotective effect of quercetin against the detrimental effects of LPS, such as neuroinflammation-mediated neurodegeneration and synaptic/memory dysfunction in adult mice. Okay, 1 week induced glial activation causes the secretion of cytokines and chemokines and other inflammatory mediators, which further activate the mitochondrial apoptotic pathway and neurodegeneration. 1 week correlated significantly reduced activated gliosis and various inflammatory markers and prevented neuroinflammation in the cortex and hippocampus of adult mice. Furthermore, quercetin rescued the mitochondrial apoptotic pathway in neuronal degeneration by regulating BAX and BCL2 and decreasing activated cytochrome C, caspase 3 activity and cleaving. These are different pathways here. The quercetin treatment significantly reversed the LPS-induced synaptic loss. It reversed the damage. Quercetin improved memory function of the LPS-injected mice. Okay, that's important to take into consideration. They evaluated the memory functions of the mice using the Y-maze test, blah, 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 blah. Okay, the Y-maze test also indicated LPS-triggered short-term spatial memory dysfunction compared to the control group. Quercetin treatment significantly enhanced the spontaneous alteration of behavior, indicating that quercetin improved spatial and working memory function. Quercetin protects against LPS-induced synaptic dysfunction. Mounting studies have reported that flavonoids are beneficial for synaptic memory. Mounting studies, not one study, mounting studies have supported that flavonoids are beneficial for synaptic and memory functions. Okay, therefore they examined the effects of quercetin on synaptic expression by the Western blot and confocal microscopy. The Western blot, blah, 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 showed that the group of mice that received the LPS had decreased expression levels and synapse, blah, 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 hippocampus compared. Treatment with quercetin along with LPS significantly reversed LPS-induced synaptic deficit by increasing the expression of PSD95 and synapse in the cortex and hippocampus of adult mice to further verify the effect of quercetin on synaptic function, blah, 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 blah. Quercetin attenuates LPS, meaning it lessens or reverses the LPS-induced activation of microglia and astrocytes. Microglia and astrocytes in the central nervous system respond rapidly to complaints such as infections, stress, and injury, which makes them important modulators of neuroinflammation. Studies have reported that in quercetin treatment along with LPS significantly reduced GFAP positive cells, blah, 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 blah. Okay, quercetin halts the LPS-induced activated TLR4 NFKP pathway. Quercetin attenuated LPS-induced neuroinflammation-associated markers. Quercetin prevented LPS-induced neuronal degeneration. The application and consumption of natural substances is the primary focus for the prevention of neurodegenerative diseases. Among natural substances, polyphenol-derived medicinal substances are important therapeutic agents for slowing the prevention of neurological disorders. Quercetin is well-approved and recommended flavonoid that has medicinal properties and protective roles in different paradigms of the central nervous system. Insult-induced detrimental effects. In this study, they also investigated the neuroprotective effects of quercetin against LPS-induced detrimental effects such as neuroinflammation-mediated neurodegeneration and synaptic memory deficits in the cortical and hippocampal regions of the adult mouse brain. Chronic inflammation or chronic neuroinflammation is a pathological cascade that occurs during the progression of several neurological disorders such as Alzheimer's disease, Parkinson's disease, FTD, amyotrophic lateral sclerosis or ALS. Okay, and this was supported, the funding came from the Brain Research Program through the National Research Foundation of Korea. Okay, authors declared no conflict of interest, right? Okay, moving on. Quercetin inhibitor and potential role in solid tumor and neurodegenerative diseases. The Janus kinase signal transducer and activator of transcription, blah, 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 pathway. Okay. So, process is inducing. Owing to the complexity of this pathway and the potential crosstalk with alternate pathways, monotherapy as targeted therapy has usually limited long-term efficacy, especially quercetin so polyphenols, especially quercetin, exert their inhibitory effects on this pathway through known and unknown mechanisms. Quercetism has shown prominent inhibitory effects on this pathway in terms of anti-inflammatory and anti-tumor activity. So it has potent anti-inflammatory and anti-tumor activity, as well as control of neurodegenerative diseases, and that's what this review discusses. And here is a little thingy-majig here. So this is showing everything that quercetin aids with. It aids through this pathway. It helps the lungs, it helps the liver, it helps the pancreas, it helps with breast cancer, it helps with brain glioblastoma. So these are the things that it's helping with, okay? It helps with Alzheimer's disease, Parkinson's disease, multiple sclerosis, again, gastric cancer, liver carcinoma, glioblastoma, breast cancer, pancreatic cancer. Quercetin helps with all of these things, including cancers and neurodegeneration from this pathway and a couple other pathways. This is about the neuroprotective effects of quercetin in Alzheimer's disease. The neuroprotective effects of quercetin have been extensively studied at low micromolar concentrations. It antagonizes cell toxicity by oxidative stress in neurons. It suppresses neuroinflammatory processes by downregulating pro-inflammatory cytokines while stimulating neuronal regeneration. So it knocks down inflammation and stimulates neuronal regeneration. After absorption, quercetin metabolites are glucuronidated, methylated, and sulfated, meaning they're bound to these other organic chemicals so that they can enter the body, and all have been shown to afford neuroprotection. The neuroprotective efficacy of quercetin has been studied in both in vitro and in vivo models. A study using drug screening, blah, 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 blah. Quercetin has shown therapeutic efficacy improving learning, memory, and cognitive functions. So think about this. Okay, so next time you're told, oh, your kid needs ADHD medication, maybe you might want to go to a naturopathic doctor. Maybe you might want to go to a naturopathic doctor or a doctor that practices integrative medicine and say, what about quercetin, doc? What about quercetin? Quercetin has shown therapeutic efficacy improving learning, memory, and cognitive functions. Another person concluded that quercetin administration resulted in the inhibition of this pathway, blah, 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 blah. Anti-Alzheimer's disease mechanisms of quercetin. Quercetin is also reported from in vitro and in vivo. It has anti-tau effects. Attenuation of oxidative stress, which means it knocks back oxidative stress through antioxidant factors. It knocks back neuroinflammation. It cools down neuroinflammation. Okay, this is another little chart here. Anti-Alzheimer's disease potential in vitro studies. Quercetin protects neurons from oxidative damage while reducing lipid peroxidation. Furthermore, given its antioxidant properties, quercetin inhibits the fibril formation of amyloid beta proteins, counteracting cell lyses and inflammatory cascade pathways, yada, yada, yada. Anti-Alzheimer's disease potential in vivo studies. The protective effects of a diet rich in polyphenols, like the Mediterranean diet, or the chimpanzee diet, or the Okinawan diet, or the Sardinian diet, etc., 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 Blue Zones diet, it protects against conditions like cardiovascular disease, metabolic disorders, infections, cancers, and neurodegenerative disorders. It has been reported in several studies that quercetin exerts neuroprotective effects when administered in vivo. That protects neuronal cells from oxidative stress induced by various chemicals and prevents hippocampal apoptosis. Quercetin improves memory, learning, and cognitive functions, and all these effects have been shown to be associated with its antioxidant properties. In vivo studies using mice as an animal model have supported that quercetin increases spatial memory and decreases beta amyloidosis, tauopathies, so it basically stops Alzheimer's. Conclusion: quercetin is a flavonoid with notable pharmacological effects. Again, quercetin is a flavonoid with notable pharmacological effects and promising therapeutic potential. It is widely distributed among plants and found commonly in our daily diet, such as in fruits and vegetables. It has beneficial properties against general mechanisms of Alzheimer's disease etiology in a variety of in vitro and in vivo models. It protects neuronal cells by attenuating oxidative stress and neuroinflammation. The Alzheimer's disease properties of quercetin include the inhibition of amyloid beta aggregation and tau phosphorylation. It restores acetylcholine levels through the inhibition of hydrolysis of acetylcholine. Okay, although showing neuroprotective efficacy in several in vitro and animal models, in vivo studies have reported that it is extensively metabolized upon absorption from the gut, affecting it's bioavailability. It also has a blood-brain barrier penetrability. It has low blood-brain barrier penetrability, thus limiting its efficacy in combating neurodegenerative disorders. Therefore, future clinical trials of quercetin and its analogs as neuroprotective agents must improve the bioavailability, developing related molecules. One of the ways around this is going to be when we start using nanobots and nanoparticles to disperse these things. Moving on. Aging and the mechanistic links between aging and lung fibrosis. Our understanding of the biology of aging has advanced significantly in recent years. This has resulted in recent formation of hallmarks of aging and loss of proteostasis, deregulated, blah, 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 blah. Disease of aging, so as you get older, you have an increased risk of lung fibrosis. Quercetin and rutinoside. Okay, so let's see here. Mice showed signs of pneumonitis and fibrotic changes in lungs following radiation treatment. So this is a radiation therapy-induced fibrosis of the lungs. Remember, radiation, smoking, pollution, it affects you by basically activating aging pathways. Things like quercetin, vitamin C, folate, these things, they deactivate aging pathways. So a dramatic increase in inflammatory cells and cytokines contributing to lung disease pathogenesis was observed. Furthermore, expression of blah, blah, blah. However, pretreatment with quercetin significantly attenuated radiation-induced pneumonitis and fibrosis. Histological examination revealed less structural and fibrotic changes with downregulation of these pathways here. The findings from the current study clearly demonstrate that quercetin provides radio protection to the lungs by regulating blah, blah, blah. Okay, moving on. Quercetin can ameliorate an acute lung injury in rats. Okay, so BDL group showed significant increase in lung index together with mononuclear cellular infiltration denoting inflammatory state. Okay, with thickening and quercetin led to significant decrease in lung index, pulmonary conclusion. Quercetin ameliorates, meaning gets rid of, the hepatopulmonary syndrome-induced lung injury through its anti-inflammatory, antioxidative, and antifibrotic effects. Quercetin ameliorates this acute lung injury from its anti-inflammatory, antioxidative, and antifibrotic effects. Quercetin, the protective effect of quercetin in alcohol-induced liver and lymphoid tissue injuries in newborns. Okay, so recently published experimental and clinical studies indicate that the oxidative stress leads to the pathogenesis and progression of alcohol-induced tissue injuries. Quercetin is a type of flavonoid compound that influences antioxidant and anti-inflammatory activities which have protective and therapeutic effects for treating various diseases, including diabetes and neurodegenerative diseases. In this study, fetal alcohol syndrome was tested in rat models with the aim of verifying the protective effect of quercetin in preventing alcohol-induced liver and lymphoid tissues injuries on the 21st day of the offspring of alcohol-treated mother rats. The pregnant rats were randomly assigned into 4 groups. The control group, blah, 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 blah. Okay, the plasma, okay, so where are we at here? So, 10 offspring were used, whereas glutathione levels, glutathione reductus, tissue, plasma this and that, significant, okay, so quercetin significantly decreased the situation with the alcohol-induced liver and lymphoid damage. Health benefits of quercetin in age-related diseases. Polyphenols are the known group of phytonutrient or phytochemicals or phytonutrients that consist of phenolic rings. These are a plant product present in varied fruits and vegetables. These secondary metabolites perform a protective function in plants from environmental and biological stress when consumed as a human diet, in the human diet, I should say. These are also known to prevent various age-related diseases. So they are known to prevent various age-related diseases. Polyphenols are known to possess antioxidant properties and protect against oxidative stress. The literature survey was carried out using a database, blah, 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 blah. Quercetin is among the widely occurring polyphenol found abundantly in nature. It is commonly present in different plant products. Onion is known to have the highest quantity of quercetin. This plant compound does possess antioxidant properties. The person that wrote this must have been like Chinese or something. They messed it up when they translated it. Anti-episode has antioxidative, anti-inflammatory, isn't it wonderful that science is a universal language, at least? Antioxidative, anti-inflammatory, anti-proliferative, anti-carcinogenic, anti-diabetic, and antiviral properties. The molecule is lipophilic, which means it likes fat, so take it with fat if you can, and it can easily cross the blood-brain barrier when it's presented with fat, okay? There's like olive oil. Various in vivo and in vitro studies have demonstrated the role of quercetin, and here a detailed review of quercetin as a curative agent in neurodegeneration, diabetes, cancer, and inflammation has been carried out. So let's take a look at these pictures here. Structure and major classes of quercetin. Quercetin from different fruits and vegetables. Mechanism of action of quercetin right here. So, structure and properties of quercetin. So it's antioxidant, anti-diabetic, anti-carcinogenic, anti-hypertensive, anti-neurodegenerative, and anti-inflammatory. And there you go. Quercetin prevents alcohol-induced liver injury through targeting these pathways here. About 90% of individuals and those who have been drinking over a long period of time develop into alcoholic fatty liver disease, and only a few will develop into alcoholic hepatitis or alcoholic cirrhosis. The results showed that quercetin significantly reduced alcoholic blah, 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 blah. So it helps reduce the alcohol-induced liver damage. In the past, the pathogenesis, yada, yada, yada. So in summary, the study showed that quercetin prevents alcohol-induced liver injury through its antioxidant, anti-inflammation, and anti-apoptosis effects. Okay, through those pathways. These results suggest that quercetin is a promising therapeutic target for alcohol-induced liver injury. So keep that in mind. These results suggest that quercetin is a promising therapeutic. Okay? So it helps to prevent alcohol-induced liver injury through its antioxidant, anti-inflammation or anti-inflammatory, and anti-apoptosis effects. So everybody's like all turned on about intermittent fasting, yada, yada, yada. So when I come back, I'm going to talk about, in my next video, I'm going to talk about ways to induce autophagy, most of which are not fasting related. Okay. And that's all for this video. I'll continue in a little bit with another video on quercetin.